Hello dear students, once again welcome back to our channel. I am your maths teacher CG ma'am. In this video we are solving the word problems of exercise 3.6, that is question number 2, and under this question number 2 we have 3 sub questions. So first we are moving to the first question, that is Ritu can row downstream in 20 kilometers in 2 hours and upstream only 4 kilometers in 2 hours. Find her speed of rowing in still water and the speed of the current. Question is clear, children? That means look at the last sentence. We have to find out the speed of her rowing in still water, okay, as well as we have to find out the speed of the current. So from there we can give the variables. What are the unknown quantities that can be here? We have two unknowns. Let it be x and y. So we are giving first the variable for x is her speed of rowing in still water is x kilometer per hour. Okay, and secondly the speed of the current. The speed of the current is actually the speed of the water. Okay, current is here, water. The flow of water is here in the sense of current. Okay, so children, see, if he is rowing downstream, okay, and here in this question we can form equation for two cases. One is upstream and second one is downstream. Okay, see, we all know water has a tendency to always flow downwards, isn't it? Okay, so her speed in still water, okay, as well as the flow of current, okay, that will together we will give the speed in downstream. Understood? The speed in downstream means that is what is the actual speed in still water, that is x kilometer per hour. Okay, and water has its natural tendency to flow down. Okay, that we have taken the flow of, that is the speed of current as y kilometer per hour. So in order to get the speed in downstream is we have to add the still water, the speed in still water and the speed of the current. Okay, that will complement, that is because water has a tendency to flows down. Okay, so in downstream we have to add the flow of current with the speed in still water. Okay, so we can write the speed in downstream. Okay, that is speed in downstream, since we have taken the speed in still water as x kilometer per hour and the speed of current as y kilometer per hour. So as I told, in case of downstream the speed will be x plus y kilometer per hour. Okay, but what happens in upstream? Okay, see, that boat is moving up. Okay, so as I told, the water has a tendency to always flows down. That speed is opposing the speed of boat in still water. That means we have to subtract. One is moving up, but water is always flowing downwards. So we have to subtract that flow of current from the speed in upstream. That means x minus, that will be the speed in upstream, that is x minus y. Here in upstream we have to subtract the flow, the speed of the current from the speed in the still water. Okay, because that is always opposing, because water has a tendency to always flows down. Okay, but we are moving that in upstream, moving upwards. So there is an opposing force. That means the speed of current, that is y, should be subtracted from the speed of the current in still water. Okay, speed in still water. Okay, that means that is speed in upstream will be x minus y kilometer per hour. Okay, and what is next, children? Okay, we have given the distance travelled in downstream and the time taken to cover that much distance. Okay, that is, it is given as the distance travelled in downstream is 20 kilometer and for that the time taken is 2 hours. Understood? And we have very famous formula to, in order to get that speed or distance or time, that formula relating to these three quantities is Nothing but speed is equal to distance by time. Okay, here children, in this question, here we have to formulate equations with respect to time, because we have given in with both cases we have given the time taken to cover this much distance, 28 kilometers for downstream, and that is given as 2 hours. Okay, so I am going, and in the same way the distance covered in upstream is 4 kilometers, and for that the time taken is also 2 kilometers. Okay, so I am going to represent this situation with respect to time. Okay, so for that we have speed is equal to d by t. So I am going to write with respect to t, that is, which implies t is equal to d by s. D by s. Okay, and in the same way we have to represent the second condition, that is time taken in upstream. Okay, here this is going to represent the time taken in downstream, that is, let it be T1. Okay, and in secondly we are going to represent that time for in the case of upstream. Okay, and for that I am representing T2. Okay, the same formula, but the distances are the different. Okay, in both cases. Okay, in the first case children, the distance travelled is 20, so 20 divided by, and speed in downstream, as I told, we have to add the speed of current. Okay, so we will get the speed in downstream is x plus y. So this is this comes in the denominator, that is x plus y is the speed in downstream. Okay, but in T2 means the time taken in the second case, that is upstream, and for that the distance travelled. Okay, that is distance in upstream, the distance travelled in upstream is 4, okay, divided by, and its speed in upstream, that is x minus y kilometer per hour, that is here comes x minus y. Is it okay children? So we have two equations with respect to time. Now we are going to get the equations with respect to time, that is T1 and T2. We have already T1 as 20 by x plus y and T2 as 4 by x minus y. Okay, and time taken for 20 kilometers of journey in downstream is 2 hours, that is given. So we can write 2 is equal to, instead of T1 that is given as 2, 2 is equal to 20 divided by x plus y. Okay, and from this you can take this x plus y to the left side under multiplication. So 2 into x plus y is equal to 20. Okay, and from LHS and RHS 2 is common, right? So 2 get cancelled, 2 in 10, 20 10 times, that means x plus y is equal to 10. Point is clear children? Okay, and from this, that is T2 is equal to 4 divided by x minus y, and the time taken in upstream is 2. Okay, so 2 is equal to the distance is 4 in upstream divided by, and its speed is x minus y. So 2 into x minus y is equal to 4. As in the first case we cancel with the 2, both are the multiples of 2. Okay, and they are, since they are connected by into sign, the same way you can cancel 2 from LHS and RHS. 2 in 4, 2 times. Understood? So x minus y is equal to 2. So now we have x plus y is equal to 10. That can be equation number 1. Here x minus y is equal to, this can be equation number 2. How we formulated the equation is clear children. That means we have represented both situation with respect to time. Okay, and we have solved by cancelling 2 from both sides, and we can simplify, and we have equation number as x plus y is equal to 10 and x minus y is equal to 2. So we are going to solve. Okay, x plus y is equal to 10, x minus y is equal to 2. So by elimination method we can easily solve this y, because both having the coefficient 1, but since they in y both one is positive, one is negative. So simply adding equation 1 plus 2 implies this plus y and minus y get cancelled, and x plus x, that is 2x, is equal to 10 plus 2, that is 12, or x is equal to 12 divided by 2, and that is equal to 6. And since we have taken x, what is x? That is speed of still water. Okay, so its unit will be kilometer per hour. That is, we got the speed of still water. And what is the second variable? That is y, that is speed of current. So you can substitute from 1. Okay, this can be equation number 1 and this is equation number 2. So from 1, what is a? We need y. We can represent this in terms of y. So y is equal to 10, and when this x comes to the RHS, it is minus x. So that is 10 minus 6, that is 4 kilometer per hour. Since we are taken x and y as the speed, so its unit is kilometer per hour. So x is the speed of still water that we have got as 6 kilometer per hour, and speed of the current as y, and that we have got as 4 kilometer per hour. This is very important problem, children. So we are moving to the next question. I hope this problem is very clear to you. Now we are solving the second question. In the second question, there are 2 women and 5 men can together finish an embroidery work, while 3 women and 6 men can finish the same embroidery work. Okay, we have to find out time taken by one woman alone to finish the embroidery work, and also time taken by one man alone to finish the embroidery work. Okay, so we have given 2 cases. Okay, in the first case there are 2 women and 5 men, and they have taken 4 days to finish the work. Okay, in the second case we have 3 women and 6 men. They have taken 3 days to finish the work. And finally what is asked? The time taken by one woman alone to finish the work, and as well as the time taken by one man alone to finish the work. So since we are dealing with a pair of linear equations in 2 variables, we can easily form 2 linear equations in 2 variables. Okay, so how that first equation can be formed? Okay, see children, here it's a joint effort by 2 women and 5 men. Okay, that means there are 2 women worked for 4 days. So we have to find out work done by 2 women in 4 days. And not only for women, there are men also. Okay, so we have to find out that work done by 5 men in 4 days. Children, this is a condition. From this we are going to form a pair of linear equations in 2 variables. Since we have to find out 2 unknowns, that they are the time taken by one woman alone to finish the work. Let it be x. Okay, let it be x. This is x days. Okay, the time taken by one woman alone can finish the work, and that of one man alone, let it be y days. This is the time taken by one man alone, and this is the time taken by one woman alone to finish the work. Yes, in the first case, children, there were 2 women and 5 men. They worked for 4 days. So children, so first of all find out the work done by one woman in a single day. Unitary method. One woman in 1 day. In 1 day. Okay, see, we have taken x days for finish the work. So one woman's 1 day's work will be 1 by x. For that children, suppose we have completed one book. that reading of one book for 4 days. Okay, how many what is the part finished in one day? That is, we have taken 4 days to finish the work. So the part of the book read in one day will be 1/4. Okay, in the same way, the time taken by one woman alone is x days. So one woman's 1 day's work will be 1/x. Okay, the total is x. Okay, and the whole is 1. So 1/x. So 1/x is the work done by, this is the one day's work by one single woman. Okay, and we have 2 women in that group. Okay, so that is if you multiply, this is unitary method we are applying. If you multiply 2 into 1/x, that is 2/x. This is the work done by 2 women in 1 day. Okay, that is 2/x. 2 into 1/x is 2/x. Understood? The same way we are applying that same method. Okay, so the man's 1 day's work is 1/y, and we have 5 men. So 5 into 1/y, that is 5 into 1/y, and we will get 5/y. Okay, so we have now the work done by 2 women, okay, in 1 day, and work done by 5 men in 1 day, that is 5/y. Understood? Okay, and accordingly they have worked for 4 days to finish the embroidery work. Okay, in all the 4 days there were 2 women and 5 men. Okay, so we have to multiply this quantity with 4. Okay, what is this, children? 4 into 2/x plus 5/y is the work done by 2 women and 5 men in 4 days. 4 into. Okay, so after that, after working these many workers, okay, in 4 days, what happened? The work completes. Okay, the work finished. Okay, that means we can represent that by 1. Understood? Okay, that means if you take this 4 to this side, okay, that is 2/x plus 5/y equal to 1/4. Okay, or you can directly write in this manner also, that is in 1 day that work completed is 1/4 of the whole work. Okay, or in this way also you will get the same equation, that is 2/x plus 5/y is equal to 1/4. That idea is clear, children? Okay, and in the second part, we have, in the second case, we have 3 women and 6 men. Okay, and they worked for 3 days. Okay, in the same way how that equation can be formed, children, that is here we have to find out 3 women's 1 day's work. Since 1/x is the 1 woman's 1 single day's work, so 3 women, 3 into 1/x, that is 3/x. Here we can write, okay, 3/x plus 6/y. Okay, this is the work done by 3 women and 6 men in 1 day. Okay, how many days they have taken to finish the same work as in the first case? They have taken only 3 days. Okay, so after completing 1 day, they have completed only 1/3 of the whole work. So you can equate this into 1/3. Or in this manner, if you multiply with 3, and for that you have to equate equal to 1. That is, this represents 3 women's and 6 men's 3 days work. So 1. So in the next step, this 3 will go to that side. Okay, so 1/3. Both cases are the same. Okay, anyhow, we have now 2 equations. Okay, in the variable x and y. Okay, that concept is clear, children? Okay, now we are going to solve this. We have done so many problems from this reducible form. See, children, this is the first equation, 2/x plus 5/y is equal to 1/4, and the second equation is 3/x plus 6/y is equal to 1/3. See children, why I said this is reducible form? Because we have here the variables are in the denominator. So we know what is the thing. We have to substitute for 1 by x. Here 2 by x is 2 into 1 by x. So in order to make the variable into the numerator, so we have to substitute this as, we have to substitute for 1 by x is equal to u and 1 by y is equal to v. So this equation becomes 2u plus 5v is equal to 1 by 4. This 4 can be taken. Okay. So to LHS, so multiplication 4 into 2u plus 5v is equal to 1 alone. The 4 we have taken. Okay. And we can use the distributive property. Okay. So that is 8u plus 4 into 5, 20v is equal to 1. Okay, so this is equation number 1. The same way, after substituting for 1 by x as u, this 3 by u become 3u plus 6v is equal to 1 by 3. We can take 3 to LHS, so under multiplication. So 3 into, okay, equal to 1. So 9u plus 18v, 3 into 6, 18v is equal to 1. This is equation number 2. Now we can solve for u and v, any one of the method, either substitution method or elimination method. Okay, so I am doing elimination method in order to get u and v. Okay, here we can't simply add or subtract, being the coefficients are not the same or not the unity. So we have to multiply this equation 1 with 9, okay, and equation 2 with 8. So what happens children, if you multiply 9 with 9 equation 1, we have to multiply each term. So 9 8s are 72u plus 2 into 120, 2 into 20 is 180 is equal to 9, both LHS and RHS. And if you multiply equation 2 with 8, okay, so 72. This is the way we can make the coefficient of the variable u the same, that is 72. Okay, and 8 into 18. Okay, 18, that is 64 and 6 carries, and 8 plus 6 is 144, and 144v, okay, 180v, and this is equal to 8. So this is equation number 3 and this is equation number 4. I have given a detailed explanation of how these equations in the reducible form can be made into the general form of pair of linear equations in the previous videos. Okay. And in order to eliminate, we have to subtract, because the coefficient are same and the sign also same. In that case, we have to subtract. Okay, that is equation 3 minus 4. Change the sign and add. Okay, that means this term get cancelled, and 180v minus 144, and that is 36. Okay, 36v equal to 9 minus 8 is 1, or v is equal to 1 by 36. Okay, now we have to find out the value of u. Okay, in order to get the value of u, you can substitute in equation number 1 or equation number 2. Okay, that means from 1, equation number 1, we have to write with respect to u, the term containing u is 8u. Okay, and we can take 2v to RHS, so minus 20v. Okay, or 1 minus 20 into v. What is v? 1 by 36. 1 by 36. Okay, and you can reduce this 20 and 36. Okay, then they both are the multiples of 4. So 5, and here comes 9. That is 1 minus 5 by 9. That point is clear, children. This is just substituting. We are substituting the value of v in 1 minus 20v. Okay. Hence, we have 1 minus 5 by 9. So, by cross multiplication, 1 into 9 is 9 minus 5 divided by 9. That is 4 by 9. And this is 8u. Understood? What we need? We need u. So in order to get u, so 4 by 8, here 9 is already there and 8 come with 9 under division in the denominator, under multiplication. So we can reduce 4 in 4 one time and 2. So 1 divided by 9 2s are 18. So now we have u and v. But what we need? We have x and y in the equation. We have taken the time taken by one woman alone to finish the work is x days. So we have to find out x. So resubstitute. Okay, that means we have substituted for 1 by x is equal to u. From this, x is equal to, x will go to RHS. So u will come to denominator, so 1 by u, that is 1 by u. What is u? 1 by 18. So 1 by 18. 1 into 18 by 1 or 1 by 18 is the reciprocal of 1 by 18 is 18. Whatever the method is easy for you, you can apply that. Okay, actually this is 1 into, if fraction comes, you have to take the reciprocal and multiply. So 18 by 1 and that is 18 days. So one woman alone can finish the work within 18 days. Okay, accordingly we have taken the time taken by one woman alone is x days and we have got now the value of x as 18 days. In order to get y, how we substituted? We substituted for 1 by y as v. So y is equal to 1 by v. 1 by v is 1 by 36. Okay, 1 by 36 is v. Okay, and take the reciprocal. Okay, that is 36 days. So for x comma y, that is equal to 18 and 36. These are the values of x and y. That is time taken by one woman alone is 18 days and the time taken by one man alone is 36 days. This question is clear, children? Okay. Now we are solving the third question. Very important problem. Okay. Here Ruhi travels 300 km to her home partly by train and partly by bus. Okay, that means she has taken two modes, that is some portion of her journey by train and another by bus, and the total distance is 300 km. Okay, she takes 4 hours if she travels 60 km by train and the remaining by bus. For traveling the 60 kilometers, this is the distance travelled in train, that is 60 kilometer by train, and the remaining, the total is 300. So the distance travelled in bus is 300 minus 60, that is 240. So together 60 plus 240 is 300 kilometer. Okay, and for this journey she has taken 4 hours. This is the first case. And in order to form the second equation, we have if she travels 100 kilometers by train and the remaining by bus. Okay, that means in the second case, she travels 100 kilometers by train and the remaining total distance in both cases 300. So 300 minus 100, that is 200 is the distance travelled in bus, by bus. And for this journey, she has taken 10 minutes longer than the first case. First case, that is 4 hours. So the time taken is 4 by 10 by 60, 10 more minutes. So to convert minutes into hours, we have to divide with 60. Okay, that means 0, 0 get cancelled, that is 4 plus 1 by 6. So 24 plus 1, that is 25 by 6 is the time taken, okay, by Ruhi in the second case to reach her house. This is a problem. So as usual, we can form the linear equation. This is very simple question. Okay, so we have taken the speed of train as x because the first is train we marked, and the speed of the bus is y kilometer per hour. And here this problem is with respect to time, because it is both are given the time taken for the journey. So we have the same, we can use the very important formula, that is the formula connecting speed, distance and time, and that is speed is equal to distance by time. Okay, since we have given the total time taken for the journey, that is 4 hours, that is with respect to time, we can write this equation, that is T is equal to D by S. So since we have two cases, two timing T1, okay, in the first case distance, okay, by train we have taken the speed of the train, okay, equal, let it be x kilometer per hour, and that of bus is y kilometer per hour. Okay, and here in order to get the first time, that is T1, and by train the distance travelled 60 in the first case. So 60 distance by speed. For train we have taken the speed as x. So 60 by x plus, okay, both together she has taken 4 hours for a travelling of 300 kilometers. So 60 by x, okay, and in the next case, that is the distance travelled is 200, and for that is by bus, and its speed is we have taken as y kilometer per hour. So that time, that is 240 kilometers by bus, and its speed we have taken as y, and for this journey she has taken 4 hours. This is the first equation. And secondly, okay, in the second case 100 kilometer by train. Okay, and so 100 divided by, and by train x is a speed time with respect to time we are forming the equation. So d1 by s1, that is distance is by train, so distance is d1 we have taken. Okay, so 100 by x plus 200 by y is equal to 25 by 6. How the equation is formed is clear, children? Yes, now we are going to solve this. Okay, see children, since here x and y comes in the denominator, it is reducible form. So we have to reduce and we have to make it the equation of pair of linear equations in two variables. Okay, yes, here see children, denominator in the RHS, denominator is 6. So you have to multiply both LHS and RHS of the second equation with 6. So children, what happens? Here 6 and 6 get cancelled. That would be better in this case. Okay, and simultaneously you have to multiply its RHS, LHS also with 6. Here already 6 get cancelled. Okay, with the number, same number 6 we can multiply LHS also. Okay, so 6 into 100, 600 by x plus 6 into, we are opening the bracket by the number outside, by multiplying the number outside. So 200 into 6, that is 1200 divided by y. Now this is free from the denominator 25. That idea is clear, children. How this 25 comes is clear. Okay. Now see the problem still, the first equation. We have 60x plus 240 divided by y is equal to 4. Yes. Now we have the first equation, that is 60 by x plus 240 by y is equal to 4. Here 600 by x. Here both variables are in the denominator, so we can give substitution as 1 by x is equal to u, 1 by x is equal to u, 1 by y is equal to v. So what happens? This reduced in the form 60u plus 240v is equal to 4. And what happens in the second equation? 600u plus 1200v is equal to 25. Okay, so children, we have to solve for these two variables for u and v. So children, how this can be, how this variable, see the coefficient of the variable can be made equal. See children, if we are marking this as equation number and this is equation number 2, if we multiply 1 with 10, you can make this as 600 because 600 is a multiple of 60. So what to do? You have to multiply equation 1 with 10. So this will be 600u, only equation 1 plus 2400v is equal to 40. Let it be equation number 3. This we got by multiplying with 60 so that you can easily eliminate. Now we have both equations having the same coefficient, that is 600. That means with the same sign, so subtraction, so minus, minus, minus. So this term get cancelled. Okay, so 1200 minus 2400, that is minus 1200v. This is equal to minus 15. And finally, v will be minus and minus get cancelled. 15 divided by 1200. Both are the multiples of, but you can easily divide with 3, that is 5 and here 400. Again you can divide with 5, so 5 in 5 one time and here 8 and 80, that is 1 by 80. This is the value of v. The same way we can substitute for u, okay, that is we can write the first equation with respect to u, that is we need u. So 60u is equal to 4 minus this minus 240. Okay, 240v, that is 4 minus 240 into 1 by 80. Okay, so 0, 0 get cancelled. And 8 in 24, 3 times, and 4 minus 3 is 1. This is 60u. We need u, that is 1 by 60. So children, now we have the value of v as 1 by 80 and u as 1 by 60. Then resubstitute. That is 1 by u is equal to x, or x is equal to 1 by 60 reciprocal, that is 60 kilometer per hour. That is the speed of the train. That is how we have taken speed of the train. And y is equal to, here we will get y is equal to 1 by v. And that is reciprocal of 1 by 80. Okay, 1 by 80 is 80 kilometer per hour. That is 80 kilometer per hour. That is x comma y is equal to, x is 60 kilometer per hour, okay, and y is 80 kilometer per hour. This is all about the last problem. I think this problem is clear to all. Okay, finally we have completed the whole problems from 3.6. I hope all these questions are clear to you. Thank you children. Thank you for watching and supporting my channel. Thank you all.